I had a question.
Yep.
These the quizzes you posted on Canvas, they're not graded, right?
Yeah, none of these quizzes are graded. I apologize that it says I just brought it from somewhere else. I will change some of the settings on the quizzes to make sure that they're not graded and stuff like that.
Um, okay, and also like last time we did sample A, and one of the questions was like find the angle between U and like minus 3U. So you said the angle would be 0, right?
Yeah. Well,
Um,
minus 3u size, that would be pi.
that'd be pi. Okay, yeah, thank you. That's all.
Okay. Sorry about that. Okay, so find the equation of the plane containing this point such that the vectors point along the plane. So again, similar strategy to what we just did with the line. We have two vectors. So we want to find the plane that contains these two vectors. So what we can do is we can find their normal vector. And that will give us the plane. And then we take the point, 2, 3, 4 to be a point. And we use the equation of the plane and a point to find the full equation of the plane. So let's do it. So 2, 3, 2, 5, 4, 2. Okay. So the vectors, okay, so we have the normal vector. And the normal vector is the vector 2, 17, and negative 14. 2, 2, 17, and negative 14. And I think at this point it does make sense to just verify, because I never actually verified that this was correct. So let me just take the dot product of this vector with this vector to see what happens. So that's going to be 1 times 2 plus 4 times 17. Yeah, okay. And then minus 5 times 14, which is going to be equal to, okay, so this is going to be 2 plus 4 times 17 is 68. And then 5 times 14 is 70. 70. Perfect. Okay, and I'll trust that it works with the other one too. Okay, so now the equation of this plane is going to be 2x plus 17y minus 14z is equal to b. So now we can plug in this point. So we get 2 times 2 plus 17 times 5 minus 14 times 4. That's equal to our b. Then this is going to be 4 plus plus 85 minus 56. And that's going to be equal to our b. So then this is going to be 89 minus 56. And that is 33. So the equation of our plane is going to be 2x plus 17y minus 14z is equal to 33. Any questions about this?
What was 254 again? I just couldn't remember what it was in the problem.
Right, so we just plug in this point into the equation to get our
Is
d.
it just the point on the plane?
Yeah, this is just the point of the plane.
Okay, thank you.
Okay, so let's do next problem. So the next problem asks us to find the point of intersection of that line and that plane. Okay. So again, if you have a plane and you have a line and you want to find the point of intersection, anyone remember how to do this?
Basically, you put the x, y, and z into the plane equation and find the t.
Perfect. So let's do that. So the equation, oh, the equation R of t2 plus t2 minus t3 plus t. So R of t, um, R of t is equal to 2 plus t, 2 minus t, and 3 plus t. And the equation for the plane is x plus y plus z is equal to, so x plus y plus 2z is equal to 13. Fine, so let's plug it in. So we're going to take this to be our x, this is our y, and that's our t. So we have plugging this into here. We have that 2 plus t times 1 plus 2 minus t, again times 1, plus 2 times 3 plus t is equal to 13. This tells me 4, 6, that's 10, and you move it to the other side, so you get 3. And then for the t's, we have t minus t plus 2t. So 2t. So now t is equal to 3 over 2. So let's plug t into here and then plug that point into here just to make sure we did it correctly. So if we plug t into r of t, well, I think regardless, we need to do that to find the actual point. So r of 3 over 2 is equal to 2 plus 3 over 2. Is equal to 2 plus 3 over 2. 2 minus 3 over 2. And 3 plus 3 over 2. That would be our point. So now let's plug it into here. So we get 2 plus 3 over 2 plus 2 minus 3 over 2 plus this would be 6 times 3, so plus 3. What is this equal to? So these cancel, and that this is 4 plus 6, which is 10 plus 3, 13. Yeah. Any questions about this? Okay, let's look at the next one. Find the equation of the plane that contains, sorry, yeah, what?
Yeah, can I see it just for a bit? The question to answer. So
So what
okay.
you end? Yeah.
Okay, yeah. I was just checking. Okay, thank you.
Wait, what would be the point? What was the answer for this one?
This is the point.
Oh, I see. Okay.
Yeah.
Thank you.
So find the point of intersection of this line and, oh, sorry. Okay. Find the equation of the plane that contains the parallel lines that and that. So let's first try to think about strategy we can use to solve the problem. So if you have two parallel lines, here's one, and here's another, and we want to find the plane containing them. So what we can do is we can first look at the vector v on one of these planes. So here's the vector v, v1 to this line, sorry, one of the lines, v1, right? Because the two lines, you have r1 of t is equal to, let's just do, yeah, r1 plus tv, 1, and then r2 of t is equal to r2 plus t v2. So we can take this vector v. Now, in order to find the equation of the plane, we need two different vectors lying in this plane, but we cannot have that they're parallel. So if I try to look at the vector v2, well, if I take the cross product between these, what would happen? And,
Wouldn't you just get the normal vector to the plane?
but not if you're using two vectors that are basically the same or parallel. So in this case, you have the vector v1, and you have a vector v2. And if you take the cross product between these, you're going to get 0. So v1 across v2 is equal to 0 if they're parallel, right? Right? And can anyone tell me there are two good ways to figure out why this is true? Can anyone remind me of them? How do we know that if two vectors are parallel, then their cross product is 0? Anyone? So one way to do it is by saying, okay, if I have two vectors that are parallel, the parallelogram spanned by them is going to have area 0. But I know that the parallelogram spanned by them also has area magnitude of v1 cross v2. So now this is equal to 0. That tells me that v1 cross v2 is equal to 0. Yeah? Definitely should always remember, if two vectors are parallel, their cross product is equal to 0. And one way to think about it is we know that the area of the parallelogram spanned by them would be the magnitude of their cross product. So if they're parallel, then their area is 0, so their cross product is 0. The second thing that we can look at is V1. We know that the magnitude of V1 plus V2 is equal to the magnitude of V1 times the magnitude of V2 times sine of the angle between them. Now, if this angle is 0 or pi, this is 0 and this is 0, so the whole thing is 0. So again, this is 0. Any questions about this?
No, we're good.
It looks good.
So going back here, we cannot use the vector v1 and then the vector v2, right? But what we can do is we can find a point on the second line. Let's say it's this point. We can form a vector from this point to this point, call it v3. This vector also lies in the plane, so now we can find the normal vector of these 2 points. And that's how we're going to do the problem. Oh, yeah? So, so let's actually do it. So any questions about how we're going to end up doing the problem? 1 plus 3t, 5 plus 2t. Let me actually, my computer's glitched a bit, so let me close some of this. Okay. So for r 1 of t, we have 1 plus 3t, 5 plus 2t, 5 plus 2t, and then 3 plus 2. And for R2 of t, we're going to have 1 plus 6t, 3 plus 4t, and 1 plus 2t. So we can definitely figure out what V1 is. So V1, and that would be useful, V1 is equal to the vector 3, 2, 1. Now let's see what V2 is, and they should be parallel. So 6, my guess is this is 4, and this is 2. And yeah, again, if you take the cross product between these two vectors, you would get 0. So you won't be able to find your normal vector. So let's stick with this guy. And let's find a point in R1. So the easiest point to choose is just R1. I generally call it R0. I just changed it a little right now. But it's a point, I don't know. And it's the point 1, 5, 3. Now, what is R of 2? That's going to be the point 1, 3, 1. So far, so good?
So you just plugged 0 for t and then you got R1 and R2?
Yeah.
Okay.
So now we're looking at the vector R1, R2. Right, the vector from R1 to R2, and that over there is this step. Yeah, that was on the other. I deleted that. Okay, whatever. So let me remake some of this. So here are 2 lines, and here's our plane. and here's the vector v1, and here's the point r1, and here's the point r2, and we want the vector between them. Okay, so that's this vector. So that is the vector 1 minus 1, which is 0, 3 minus 5, which is negative 2, and 1 minus 3, which is negative 2. So now that we have these two vectors, we want to find the normal vector. So the normal vector is going to be equal to v1 cross r1, r2, which is equal to I, j, k, and then we're going to have the vector 3, 2, 1, and 0, negative 2, negative 2. Okay, so this is going to be I times 2 minus 2 is 4, is minus 4, and then minus, minus, so plus 2, minus j times 3 minus that is negative 6, and 0, so this is just going to be positive, plus k times negative 6. So this is equal to the vector negative 2, 6, and negative 6. Okay, but it does not. Okay, let me look at this again quickly. 4, oh, minus. Oh, no, sorry, 4, yeah, minus. Okay, so that's negative 2. Let me just see. This does not, so if I take this point and I multiply it and I dot it with this vector, what do I get? I get negative 6, and then I have 2 and minus 2. Oh, yeah, that works. Okay, yeah, negative 6, plus 12, yeah, perfect. Okay, so that's my normal vector. Now, let's just take a point on the plane. So R1 is a good point on the plane. Why not? So the point 1, 3, 1, 5, 3. So my plane is going to first be negative 2 x plus 6y minus 6z is equal to some point d, some number d. So now let me plug this point in to find my d. So this tells me negative 2 times 1 plus 6 times 5 minus 6 times 3 is equal to d. That tells me that 2 plus 30 plus minus 18 is equal to d. 2, so this and this give us 12, and like should be 14, I think. Okay. Any questions?
How do we get 0, negative 2, negative 2 for the component?
This, we're just looking for the vector from R2 to R, sorry, from R1 to R2. It's 1 minus 1, which is 0, 3 minus 5, which is negative 2, and 1 minus 3, which is negative 2.
Thank you.
No pleasure.
Wait, if it was going from R1 to R2, oh wait, I understand. Never mind. Thank you.
Okay, that's the third question. Okay, so fine. I'm gonna continue this in the second class. If you guys want to join, you're more than welcome, and you don't have to. You can do it by yourself. But I think I'm going to stop here. And I don't think I have time to do a whole other question. Are there any questions about any of this? Like I said, these are not graded. So anything that makes it seem like it's graded is just a mistake. And
So I know you mentioned that we were supposed to get some sort of like sign up thing for the quiz. Is that like a thing? Or is it just gonna kind of appear like the 3 test quizzes are gonna appear in Canvas?
What do you mean a final thing for the quiz? I'm not really.
Oh, like I know you mentioned at the beginning like that we had to sign up for a quiz slot and I didn't get
Oh,
any
yeah. So
regarding
that's
that.
what I thought, because that's what I was told then, but I haven't really been told. Wednesday, I'm gonna meet with Joe again, so I'm gonna. Oh, but then I'm gonna email you. We're gonna figure it all out. It's not a big deal, and I'm gonna.
Okay, thank you.
Okay. Anything else?
Are we able to take the quizzes multiple times?
So I believe that the idea was that you can take 2 or something like that. But again, I'm gonna get back to you on that. I think last time I spoke to Joe, he said that he would allow people to take 2. Although there was some, I think, because he said something about he would only take the lowest one. I don't know. It didn't make sense. My recommendation is find one of them that you want to take and take it. I don't think you're gonna get the highest one out of 2 that you take. I don't think they're gonna give that to you. Anything else?
Professor, can I see the last answer?
Mm-hmm. 1 second. Uh, yeah.
Is your D 14?
Wait, my D on this
Yeah.
one. This 14. Yeah, I got. I didn't like necessarily think too much about it. But oh, this is negative, so it will not be 14. Yeah. But whatever that is. Yeah. Okay. Any other questions? Okay, fine. So like I said, I'm gonna be continuing doing problems. Next class that I'm giving, which is same section, so it's the same stuff, and that would be at 10:35. So if you want, you can join, or no, you don't have to. And I'll see you next time.